So in this problem, we need to determine the coordinates of the incenter of a triangle having vertices 1, 4, 4, 1, and 4, 5. So let's try to understand the problem first. So here we have a triangle ABC, and the coordinates of A, B, and C are given as x1, y1, x2, y2, x3, y3. Now here we have also specified the sides of the triangle by the letters A, B, and C in lowercase. Now clearly the letter A is the side opposite to angle A. B is the side opposite to angle B, and C is the side opposite to angle C. Now in this particular case, since the coordinates of the vertices are known and also the sides of the triangle are known, then using this information we can find out the coordinates of the incenter of the triangle. And this is given by this particular expression where we can find out the x coordinate by multiplying A with x1, B with x2, and C with x2, taking that sum and dividing it by A plus B plus C. Similarly, we can find out the y coordinate. So in our case, we have the vertices, coordinates of the vertices that's being provided to us. So let us suppose that the coordinate of A is denoted by 1, 4. Coordinate of B, let's say it's denoted by 4, 1. And coordinates of C, that's denoted by 4, 5. Now our goal will be to find out the coordinates of the incenter. Now we have one of the information, that is the coordinates of the vertices. So we also need to find out the length of the sides of the triangle. That means we need to find out A, B, and C. Now in order to find out the lengths of the sides of the triangle, that's not a big problem. All we can do is use the distance formula, because here if we want to find out the length of A, all we need is the coordinates of the endpoint. So that's B and C. Now that we have B and C, we can easily find out the length of A. Similarly, we can find out the length of B as well as length of C. So let's do that. We will begin by first computing the length A. So A, which is BC, all we have to do is use the distance formula. So we'll take the square root. Underneath the square root, what we need is the difference of the x coordinate. So we'll have x2 minus x3 and then square this. We are going to add it to the difference of the y coordinate. So that's y2 minus y3 whole square. Fine. So let's plug in the value. So what is x2? x2 here is 4 and x3 is 4. So we have 4 minus 4. So that's simply 0 square. Then we add it to the difference of the y coordinate, y2 minus y3. So we have 1 minus 5. So 1 minus 5, that's going to be negative 4 square. Fine. So this is going to give us the value 4. Let's find out the value of length B. So we'll take the square root. Underneath the square root, we need the difference of the x coordinates. Since we are finding out B, so we need the coordinates A and coordinates B. So here we can take x3 minus x1, or we can do x1 minus x3. Only difference will be there is a sign difference, but since we are going to square it, it's not going to be a big issue. Plus difference of the y coordinates, so that's y3 minus y1 whole square. We'll take the square root. Underneath the square root, we need x3 minus x1. So x3, that's 4. x1, that's 1. So we have 4 minus 1, which is 3. We have 3 squared. Added to, we need y3 minus y1. So that's 5 minus 4. So that's 1. So we have 1 square. 3 square is 9. 1 square is 1. So we have square root of 9 plus 1. That's going to be square root of 10. Then let's find out the value of C. So C is going to be, we'll take the square root. Underneath the square root, we have the difference of the x coordinate. So that's x1 minus x2 whole square. Add it to y1 minus y2 whole square. So this will be equals to, we'll take the square root. Underneath the square root, we have x1 minus x2. So that's 1 minus 4. So that's going to be negative 3. Negative 3 squared. Added to y1 minus y2. So that's 4 minus 1, which is 3. So we have 3 squared. And this is going to give us a value 3 times square root of 2. So we have successfully found out the value of A, B, and C. Now we are ready to find out the coordinates of the incenter. So this is going to be, so we need A times x1. So A is 4. x1, that corresponds to value 1. We have 4 times 1. Added to B times x2. So what's B? B here is square root of 10. So this is multiplied to x2. So x2 corresponds to 4. Plus we have C times x3. So C value, that's 3 times square root of 2. Multiplied to x3, which is 4. Divided by sum of the sides. So that means we need to add A, B, and C. That's going to be 4 added to square root of 10 added to 3 times square root of 2. Fine. Now we'll find out the y coordinate. So we need 4 times y1. So 4 is simply A times y1. So A is 4. So we have 4 multiplied to y1. So y1 has the value 4. 4 times 4 added to, we need b times y2, so b is square root of 10. This is multiplied to y2, which is 1. Added to c times y3, so c is 3 times square root of 2, multiplied to y3, so y3 is 5, divided by sum of the sides, where 4 plus square root of 10 plus 3 times square root of 2. Fine. So now we have I multiply, so I, the coordinates of the incenter, 4 plus 4 times square root of 10 plus 12 times square root of 2, whole divided by 4 plus square root of 10 plus 3 times square root of 2. Then we have the y coordinate, so that's 16 plus square root of 10 plus 15 times square root of 2, whole divided by 4 plus square root of 10 plus 3 times square root of 2. Fine. Now this is going to be the coordinate of the incenter of the triangle ABC.